So for our first hands-on experiment, we'll be making the LED blink, and for this project we'll need a breadboard, an LED light emitting diode, a resistor of preferably 220 ohm, but 1k ohm resistor would also work, and we need some jumper wires. Preferably for this experiment we'll need a male to male, which has 2 pins at the ends, 2 pins, yeah. And lastly, we'll need the Nyarkoa payload, the Cansat payload. This will be a microcontroller and a micro USB to connect the microcontroller to the computer. So to start the experiment, we're going to place our breadboard over here, and taking my LED, I'll be using the green LED. So the LED has, to know the polarities, you can see that one leg is long and one is short. So the longer one is the positive terminal, and the shorter one is the negative terminal. So we're going to connect the positive leg through a resistor onto a pin on the microcontroller, and the shorter one, which is the negative terminal, directly to ground on our microcontroller. So let's insert this on our breadboard now. So for me, I'm placing my positive on the right side and negative on the left. So we place it gently inside, make sure it sticks in well and is firm. Okay, so over here, this is my positive and this is my negative. The left one is my negative and the right one is my positive. So let's connect the negative to ground now first. So you take your Nyarkoa microcontroller, your Cansat payload, and we are going to look for ground. As you can see here, it's boldly labeled here as ground. So this is the ground hole. As you can see, it's labeled written there. So this is the 3-volt pin, ground, 5-volt pin, ground, 5-volt pin, and the input voltage. The holes you see here are not going to be used in this session because this is like the external power and ground sources for if you want to solder on it. But for now, we're going to use the pin holes here. So let's connect the jumper wire 1 pin into the ground hole firmly, good, and it's going directly to the negative of the microcontroller, which is the left pin for me. So as you can see, it's connected to the left side of it, the negative side. Now let's connect our resistor. So we need a resistor to the positive leg because the microcontroller is going to be powered with 5 volts, and normally LEDs don't need more than 2.2 volts. So the resistor is going to reduce the voltage for us, or the current. It's going to reduce the voltage for us. So we are going to connect one leg of it. So I'm going to plug it in directly, and we're going to bring it out through a different side. So make sure it fits firmly inside. Let me get this done. Yes, and connect it to a different side so we can continue the connection. So as you can see here, I've connected I've connected the positive side on this line. So each line is the same. From here to here is the same. It's the same as from here to here, and here to from this hole to this hole is the same. But this side differs from this side. So I connected one leg of the resistor to another side, and we are going to continue the connection onto the pinhole. So here we are going to continue from here onto the digital pin 9. On the code that I'll write, I'm assigning our LED pin to digital pin 9. So as you can see on the microcontroller, you can see digital, and it's numbered from 0 to 30. So here starts from 8. The rest start from here, D2 to 7. But I'm putting mine on 9, so we are going to locate it here on pin 9. So digital pin 9 will come here. So this is the connection now, directly to pin 9 through the resistor to the positive side of the LED and the negative side of the LED onto ground. Yeah. Now let's power it. Now let's connect our Arduino to the computer. Hello, so now I've launched my Arduino IDE and I've named the sketch LED blink. So first of all, before we start, let's ensure that our link that we provided in the WhatsApp page is inside our preferences. So go to File, so open File, select Preferences, and click on Additional Boards Manager URL. So ensure that you have copied this first link, raw GitHub user content electronics Cansat main Nyarkoa index.json. Then after that, you click on OK. Let's go to our tools and ensure that we select the Cansat AVR boards, which is the Nyarkoa payload. In previous videos we discussed how to achieve this level of seeing the Cansat AVR boards in your board manager. So we ensure that we click on it, ensure that you have selected the right port. Mine is COM7, and also the programmer is set to AVR ISP. So now we can begin with our code. So first of all, let's define our pins. So the LED pin, and I am assigning it to, looking at the video of when I was doing the connection, I connected the positive side of the LED to digital pin 9. So we're going to select pin 9 here and we close the statement. In our void setup, we are coming to declare, using the pin mode, we are coming to declare that the LED we have inserted, it's going to be an output. It's going to give out something, light. So in this case, light declared out. So now we are coming to give an instruction to the microcontroller to do something with the LED. So we're going to digital write LED should be high. High means on, so it should be high for about, so the delay is talking about the time in which the LED should be high. So we're going to say it should be high for about 2 seconds. In this case we are using milliseconds, so instead of writing 2, we need to write 2000, because 2000 milliseconds is equal to 2 seconds. Then we close our statement. And also we are come to digital write it, because you see we want the LED to blink, so we are come to set a time for when it will also be off. So in this case it's going to be LED low. Low means for off, so high it's for on and low is for off, basically like zeros and ones. So the 0 is referring to low and 1 is referring to high. Close our statement, and we want to keep it off for also 2 seconds. Keep it off for 2 seconds, and that's it. Then we compile our code to ensure that everything is working well. So make sure you and take notice, because this is C language and it's caps lock sensitive. So ensure that beginning starts with a small, and by the mode begins with the big M, and then the digital write has a capital W inside it, to ensure that to know if it's working, the text color is supposed to change from black to blue, and also our high and low and output must be all in caps, high caps. So you see that it turned blue to show that it worked. So let's compile the code just to check if there are no errors. Great, now we're going to compile. Let's compile. Now the code is done uploading, and you can see it being connected to the computer and the microcontroller, and we can see that the LED is off for 2 seconds and on for 1 second. So 1 2 off, 1 2 on. So now let's make some adjustments to see. We can make the delay for it being on, so let's say to 5 seconds, and the off for 1 second. Let's run the code, upload. So now it's uploading sketch. Let's wait for it. As you can see, it's going to be on for 5 seconds, off for 1 second, and on for 5 seconds. So yes, that's one way you can play around with the code. Thank you.